All right, so we're going to talk about a special kind of sequence today, an arithmetic sequence. Very, very nice, like I said, nice, friendly kind of sequence. There is an arithmetic sequence has a common difference between any two terms. So what that means in symbols, what we're doing is we're to get the next term, we just add a constant to the previous term. So the way we write that out is that a sub n minus a sub n minus 1, so one term minus the previous term, equals some constant. And d is our common difference. So we should subtract any two consecutive terms, and we always get d. The other way we could write that is if I want the next term in my sequence, I add d to the previous term. So we'll just keep adding a number to our previous term to get our next term. So it's nice, easy. The pattern is easy, and that lets us figure out some things about arithmetic sequences. So for example, let's look at the sequence 5, 8, 11, 14, comma, dot, dot, dot. What would be d here? 3, right? We're adding 3 to each term to get the next one. So d equals 3. How about the sequence 15, 11, 7, 3, dot, dot, dot. Minus 4. D equals minus 4. We're subtracting 4 each time to get the next term. And we can keep going. So arithmetic, the pattern is very simple with arithmetic sequences. One nice thing about having a simple pattern is it lets us figure some more things out about this sequence. So one nice thing that we like to figure out is, can we find a formula for any term in the sequence? So we just plug in 20 for the 20th term and get what our 20th term is going to be. So let's look at that. So we call this our nth term formula. So we just want a way to figure out what the 20th term, what the 75th term is, etc., etc. So I'm going to start with a sub 1. If I start with a sub 1, a sub 2, we're adding d. That's going to be a sub 1 plus d. A sub 3, I'm going to add d to this term. So what do I get when I add a sub 1 plus d plus d? A sub 1 plus 2d. A sub 4, I'm going to add d to this term to get the next term. So I get a sub 1 plus 2d plus d, which is 3d. And I go a sub 5 for the next one. A sub 1 plus one more d. 4d, dot, dot, dot. So our pattern, yes?
Why is it not like a sub 3 equals a 2 plus
that is what we're doing. So a2 is a sub 1 plus d. So I'm just adding d to that.
Oh, okay.
Each time. So a sub 3 is this. I add d to that, and I get that.
Okay.
So we want to. The reason we're writing it out like this is to have. So all we have to worry about is a sub 1.
Okay.
So what's our pattern going to be? A sub 1 plus n minus 1 times d. And there is our nth term formula. All we have to do is know a sub 1 and d, and we can plug in n and get any term in our sequence. So there is our nth term formula.
that going to be the same all the time, like for every sequence?
For an arithmetic sequence, this is always true, which is one nice thing about arithmetic sequence. All right, let's look at an example using this nth term formula. Let's say we want the nth term. We have an arithmetic sequence. And the reason we're telling you that we have an arithmetic sequence is that lets us know that we can use these rules for arithmetic sequence. We want the nth term arithmetic sequence with d equals 5 and a sub 1 equals 9. So all I have to do is plug into my formula. A sub n equals a sub 1, so that's 9, plus n minus 1 times d is 5. And I'm just going to simplify this a little bit. I'm going to distribute the 5. So a sub n equals 9 plus 5n minus 5. And then I'm going to rewrite this. So I get 5n plus 4. So this would be my formula that I could use to find any term of this sequence. Plug in n equals 1072, and I would have the 1072nd term of this sequence. Nice, easy formula. Okay, we're good there.
Wait, do you have to simplify it to do it, or could you just...
You could do it from here. It just this is a little less work to compute, and it looks a little nicer. All right, we good? Okay, let's look at a little more challenging problem, just a little bit. Let's say we have an arithmetic sequence. We want the nth term. Arithmetic sequence with the fifth term equals 19, and the ninth term equals 27. All right, so for our nth term formula, what two things do we need? What two pieces of information about our sequence do we need to have for our nth term formula? D and a sub 1. Two pieces of information. We have two equations here. So what does that suggest this problem is going to involve? Two equations, two pieces of information, system of equations. So we have two variables, two equations. So let's write our equations. We have a sub 5 from this piece equals a sub 1 plus n minus 1, 5 minus 1 is 4, 4 times d. And that equals 19. And a sub 9 equals a sub 1 plus n minus 1, it's 9 here, 8d, and that equals 27. Here is my system of equations. Two equations, two unknowns, a sub 1 and d. Now what's going to be an easy way for this system of equations to get rid of one of the variables? Just subtract. What were we going to say, fella?
Where did you get 4 and 8?
This one?
Yeah.
Remember our nth term formula, a sub n is a sub 1 plus n minus 1 times d. And here n is 5 for the fifth term. Okay? And this is the ninth term, so n minus 1 is 8. Okay? All right, so what did we say? Subtract? So let me rewrite this. So I'm going to put this equation on top. So I get a sub 1, not 8 sub 1. A sub 1 plus 8d. I'm going to erase this. Equals 27. and a sub 1 plus 4d equals 19. And I'm just going to subtract the bottom equation from the top. So when I subtract, I get 8d minus 4d is 40, and 27 minus 19 is 8. It's going to work out nicely. Divide by 4 and I get d equals 2. Now I have d equals 2. How do I find a sub 1? What do I do? Put d into one of the equations. I have two equations I can plug d into here. So I have a sub 1 plus 4 times 2 equals 19. So 2 times 4 is 8. Subtract that from 19. I get a sub 1 equals 11. And now we want the nth term. We want our formula for the nth term. So now we're back to the problem just like we did just before this one. Plug these two numbers into our nth term formula. So a sub n is a sub 1, 11, plus n minus 1 times d. And I'm just going to simplify that. D is 2. Simplify that so I get a sub n equals 2n plus 9. And that would be the nth term formula for this arithmetic sequence. So anytime we have a problem like this, we can set up a system of equations. Does anybody see a different way we could go about this? Yes. Yeah. So what Olivia said was, we see that these two are how far apart? 8, and there are 4 terms between them. So we could get d from that, right? Because we go 4 terms and we have to go 8. So that would tell us that d equals 2. And then every term has to be 2 apart. So then we could kind of go backwards from a sub 5, right? Yeah. That's another way we could do it. That's a little more difficult if the terms are further apart, or if you have like the 3087th term and you work, but it's also, it does work. It does work. All right, questions on that example? All right, the other nice thing about arithmetic sequence is, because the pattern is nice and simple, we can find a sum. We can add the terms, and we can find a formula for the sum. So I'm going to call this, we'll call this the sum formula. All right, so let me write out S sub n. We're going to write out a sum. So I'm just going to write this out. So this is going to be a sub 1 plus a sub 1 plus d. That's the next term. I keep adding d. Plus a sub 1 plus 2d. Plus a sub 1 plus 3d. Plus dot dot dot. And we're going to go all the way to a sub n. So we just keep adding d to get, and we're adding our next term on there. Now the trick that we're going to use to find our formula is now we're going to write this in reverse. So I'm going to start at a sub n. If I start at a sub n and I go backwards, rather than adding d, what am I going to do? Subtract. I'm going to subtract d each time. A sub n plus a sub n minus d plus a sub n minus 2d plus a sub n minus 3d plus dot dot dot, and then when we go backwards all the way, we get to a sub 1. Now if I add these two together, I have a plus d and a minus d here, a plus 2d and a minus 2d here, plus 3d minus 3d. What's going to happen to all those d's if I add those two equations together? They're going to cancel. They're going to go away. They'll add up to 0. So I'm going to add two of these. I'm going to add these together and end up with 2. S sub n plus S sub n is 2 of those. 2 S sub n. And when I add these together, I get a sub 1 plus a sub n. I'm going to put these in parentheses. Plus, these two go away, and I get an a sub 1 plus a sub n there. plus, add these two together, I get an a sub 1 plus a sub n there. Plus, add these two, I get an a sub 1 plus a sub n there. And all the way plus dot dot dot, and I'm going to say a sub 1 plus a sub n. Yes? I'm sorry, so you want to take this a sub n? Oh, so hang on for just a second, you'll see why we did it this way, okay? So how many terms do I have here when I do s sub n? How many terms am I adding up? N terms. So how many of these am I adding together? N. So if I add something together n times, that's the same as doing what to it? What do I do with the n? So if I add 2 together 5 times, what am I doing to the 2? Multiplying by 5, right? So I'm multiplying by n. So this is 2s sub n equals n times a sub 1 plus a sub n. And finally, that gives me my formula. A sub 1 plus a sub n over 2. So to find the sum of an arithmetic sequence, there's our sum formula. We add the first term, we add the last term, multiply by the number of terms we have, and divide by 2. So that's why we kept the a sub 1s and a sub n's together. And we just found a formula for a sub n. We know how to find a sub n. That's our nth term formula. So this is a really easy formula to work with. We need to know our first term, our last term, and how many terms we're adding together. And we know how to find our a sub n if we don't have our formula for a sub n. Yes?
So all that stuff above that,
That's how we get to this formula. If you know this, you're good. It's just nice. It's a nice, easy way that we get this formula. So we can get formulas easily. It's nice to know that they don't just magically appear out of thin air. All right, let's look at an example using this formula. Okay. Let's say we want the sum n equals 1 to 20 of 7n plus 1. First off, we need to know, is this sequence arithmetic? Let's take a look. Let's write some terms. So what's our first term? 7 times 1 is 7 plus 1 is 8. The second term, plug in n equals 2. 2 times 7 is 14 plus 1 is 15. Third term, 3 times 7 is 21 plus 1 is 22 plus dot dot dot. Is that arithmetic? What's D? 7. What's a sub 1? 8. And a sub n? A sub 20? We're adding 20 terms here. Just plug 20 in here. This tells us how to find our 20. This is our formula for the nth term. So a sub 20 is 7 times 20 plus 1. 7 times 20 is 140. Plus 1 is 141. So S sub n, our sum, is, how many terms are we adding? From 1 to 20. So n equals 20. 20 times our first term, 8, plus our last term, divided by 2. Plug that in my calculator and I get 1490. The 20 comes from the fact that I'm adding together 20 terms. First term, last term, the number of terms divided by 2. What would happen if I did this all and I came up with something like 148.5? What would that tell you? What's that? You did something wrong. Can we add whole numbers and get a fraction? I hope not. So if you end up with a fraction when you find this sum, you've done something wrong. And there is a story. One of the most famous mathematicians ever is named Friedrich Gauss. And the story goes that his teacher in elementary school gave the students a bunch of numbers in an arithmetic sequence to add up. And he figured out this formula in his head. So they gave him, the story was it was from 1 to 100. And in elementary school he figured out that you do this formula and he was able to write it down really quickly. So in elementary school, the story is that Gauss figured out this formula in his head when he was in elementary school. He's one of the most famous mathematicians of all time. Kind of an interesting little story there. All right, we good there? All right, let's look at one more example, and then I want to. We are not going to do the following example. I just want to talk about it a little bit. All right, we want the 15th partial sum of this sequence. First off, is this arithmetic? Yeah, D equals 3. A sub 1 equals 2. We want the 15th partial sum, so we need the 15th term. A sub 15. How do we find A sub 15? How do we find our 15th term? A sub 1 plus n minus 1, so n minus 1 is 14 times 3. And this equals 44. So now we have everything we need. S sub n equals, how many terms are we adding together? 15 times a sub 1, 2. A sub n, the 15th term, 44. Divided by 2. Calculate that out and we get 345. So nice easy formula to work with. All right, questions on that example? All right, this last one I don't want to work all the way through. I just want to talk a little bit about how we'd set it up. So let's say we have an auditorium. And there are 2 more seats in each row than the previous row. And let's say we have, the first row has 30 seats. And we have 40 rows. And we want the capacity, how many seats, what is the capacity of the auditorium? So how could we set this problem up? Using the ideas that we've just been talking about. Would the rule that represents the number of seats in the rows be an arithmetic sequence? Yeah, what's D then? 2. D is 2. A sub 1, what's our first term? 30. And we have 40 rows. So we can find A sub 40, right? Is A sub 1. 30 plus 39 times 2. And then we can plug those numbers into our sum formula, just like we did the last time. Like this. So this would be an arithmetic sequence. This problem is essentially what we did in the last problem. Set it up just the same way. All right, questions? Okay. There's the homework. There you go.